We will move on to the next question.
Sports cars usually have a friction factor. Usually have a friction factor of around 0.32. If the car has a width of 1.8 meter and height of 2 meter per day, determine the power consumption by consumed by the car where it is going at 90 km per hour with no wind blowing. Part B. Repeat part A. If the wind blows at a velocity of 25 km per hour opposite to the direction of car. Now part C. Repeat part A. If the wind blows at a velocity of 25 km per hour, blowing at velocity of 25 km per hour, and density of car at its operating temperature is 1.2 kg per meter cube.
So let's understand the question. So we can assume car as a box. So we are assuming car as a box with width that is equals to 1.8 meters and height equals to 2 meters. So this is car and this is moving in a direction Vx or minus Vx, whatever we take. So this will feel some drag, and this drag will defined by friction coefficient that is equals to 0.32. So it will affect the motion of car, and it will so car needs to give a constant power to move in that direction, and we have to calculate that power. SA is no wind, so car is moving with velocity of 90 km per hour, and wind is adding nothing to it. In case B, wind is flowing opposite to the Vx, so V wind is again adding to the friction of car. So we will add Vx and V wind in this case. And in case C, wind is flowing opposite to this direction, that is means with the direction of car. So it will reduce drag because air is flowing in this direction and drag is generated by air. So if air is moving in a similar direction, it will reduce the drag. So the effective wind speed will be Vx minus Vv. So now let's move on to the solution part.
So, moving towards solution part, our given is drag coefficient which is equal to 0.32, which is we called as CD. Width of car is 1.8 meter. Height is equal to 2 meter. Frontal area is equal to 2 into 1.8 meters per second, which is equal to 3.6 meters square. Air density is given by 1.2 kg per meter cube, and car speed is equal to 90 kilometer per hour. After converting into meter per second, we will multiply it by 5 by 18, which is equal to 25 meter per second. Okay. Here we are required two main equations, which are the first one is our drag force equation, which can be written as Fd is equal to half rho CD A into velocity square. As you know, our rho is equal to density, CD is equal to drag coefficient, A is equal to area, and V is equal to velocity. And another one equation is power consumed. Power consumed can be written as Fd into CD. Power is equal to Fd into velocity, and which can be written as half rho CD A into VQ. Now, solving the case A, which is no wind case, we are going to solve here. In first no wind case, we are going to find power consumption. Here we write the formula of power, and now we are putting the values one by one. Half our density is 1 by 2, and CD is or CD 0.32, where area is equal to 3.16, and our velocity is equal to 25 meter whole cube. So after solving this one goes cancel out, and 6 into 2, 12, 1, 6 into 3, 92, 3.6, 625, and after solving this, so our answer is 10.8 kilowatt. This is our power consumed in our first case. So now moving to our case B. Here in case B, wind blows opposite at 25 kilometer per hour, which is 6.94 meter per second. Here, while this is moving in opposite direction of car, which is 25 km per hour, here we will get new velocity, that is called effective velocity, and here we are writing the effective velocity. Our effective velocity will be and that is equal to 31.94 meter per second. Here basically we have to find power, and for power we applying same formula of rho Cd A VQ. Now putting the values. Cd area was 3.6 and new velocity which is equal to 31.94. After solving this in Cal C, we are getting power is equal to 4.07 kilowatt. This is your power consuming case B, where wind blows opposite at 25 km per hour. Now, further moving toward the last part of this question, which is part C. Wind blows with the car. Wind blows with the car velocity at 25 km per hour, which is equal to 6.94 meter per second. Here the effective velocity will be effective velocity 25 minus 6.92, and our resulting velocity will be 18. Basically, here wind blows with the car velocity. Basically, car goes in this direction and wind also goes with this direction, and our effective velocity is getting this. So here also we have to find power consumption from above formula by putting the values 1.2 Cd 0.32, area 0.6, velocity 80. After solving this equation calculation, we are getting 4.07 kilowatt. This is our answer of part C, and here in this way we solved all three part of and three cases of this question. This will our final answer. So moving toward the last part of our series. So our last question is 3 parallel plate, flat plate, are separated by 2 fluids as shown in figure. What should be the value of Y2 so as to keep the plate in middle stationary? So as to keep the plate in middle stationary, if V2 is equal to 123 centimeter per second, centimeter per second, and V1 is equal to 234 centimeter per second, and Y1 is equal to 3.4 centimeter.
So we have 3 plates and we have to keep this middle plate stationary. Means it is not moving, so its velocity will be 0 and there will be fluid. Here is the fluid. With viscosity mu equals 1.23 centimoles. So we have to calculate this y2 distance so as to keep this center plate stationary. So I'll call Srikanth for that, for solution part.
So moving towards the solution part. So first of all we write given data. Given data is V1 is equal to 134 centimeter per second. Sorry. This will V1 is equal to 243 centimeter per second, and Y1 is equal to 34.5 centimeter, and we have to find Y2. The previously my friend explained about the diagram. We have to balance our shear stress. So this is mu. There are two fluids, both have same mu. This is V1 and this is V2. And our middle plate is kept stationary. V is equal to basically 0. By shear balance, to keep middle plate stationary, we are applying the formula mu V1 upon Y1 is equal to mu V2 upon Y2. Now putting the values, our both mu were same, mu cancel out. V1 is equal to 243, where Y1 is 34.5 centimeter. V2 is 134 upon Y2. So after solving this, our Y2 will be 1.8 cm, and this is the answer. This is the distance of second plate from the stationary plate to keep this middle plate balance, stationary.